Hey guys, this video is on why slope-intercept form is important. You may be really confused right now about why we're dealing with all these equations and why there's so many of them, and then why we're focusing on slope-intercept form. Hang tight, get your notebooks out, and we're going to talk about why slope-intercept form is important. The reason why your teachers are so in love with slope-intercept form is because it is useful and easy. When you're given an equation in slope-intercept form, it is so easy to identify the slope and the y-intercept just by looking at the equation. Now, if you remember from my video before this on the three types of equations, the m represents the slope of the equation. That's right here in red. M represents the slope, and B is right here in blue. It represents the y-intercept. Notice the slope is the value being multiplied by x. And then the y-intercept is the other number being added or subtracted to the equation when it's in this form. So let's do some practice. I'm going to do the first one for you, and then you can pause the video and practice finding the slope and the y-intercept on your own for these others. So I'm going to find the slope of the equation y equals negative 2x minus 12. And I know that the number being multiplied by x is going to be my slope. So my slope is negative 2. Because negative 2 is being multiplied by x. And I know that the other value is my y-intercept. And you've got to get the whole thing. So notice this is a minus 12, which means its value is negative 12. So my slope is negative 2, my y-intercept is negative 12. Okay, so go ahead and pause your video and figure out the slope and the y-intercept for each of these next equations. Okay, I hope you had time to identify the slope and the y-intercept for this next one. So we have y equals negative 5 minus 3x. Now this one's written a little bit differently because the x is written in a different position, but the values are the same. So the number being multiplied by x is a negative 3, so that's going to be your slope. And the other number on that side of the equation is a positive 5. So positive 5 is your y-intercept. Go ahead and pause your video again, and then try and find the answers on your own to this next one. Okay, we have y equals 6x. Now this might confuse you because there's not anything else there. But like we learned in my previous video, if there's nothing else there, that's the same thing as saying plus 0. So this equation could be rewritten as y equals 6x plus 0, which means that the slope would be 6, because that's the number being multiplied by x, and our y-intercept would be 0. That doesn't mean we don't have a y-intercept. It means it crosses at the origin where y value is 0. So that's what it is for this one. So don't get tricked if you see an equation that looks incomplete. It probably just means there's a plus 0 that is redundant for us to write. You just have to remember that it's there. Go ahead and pause your video and find the slope and the y-intercept for the next one. Okay, so this one is also a tricky one. You have y equals 4 and no x's. That's 0 x's. So once again, it would be redundant in math for us to write all the zeros in the equation. That would just be silly. It would take a lot of time. That's unnecessary. But know that there's no x's in this equation. None. That means your slope is 0. Because 0 times x equals 0. So your slope is 0 for this equation, and then the other value that exists is 4. So your y-intercept for this equation is 4. So now that we've found the slope and the y-intercept for all of these equations, what is the point? What are we going to do with it? Okay, so now that we have our slope and our y-intercept for each of our equations, it becomes very easy to graph. So I'm going to go ahead and do the first one for you as an example, and then I'd like you to pause the video and work on graphing these on your own. So for our first equation, y equals negative 2x minus 12, we identified that our slope was negative 2 and our y-intercept is negative 12. Well, the y-intercept is the location where our line crosses our graph. So we're going to count down -12, and hopefully there's enough room on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So down here is the location -12 for our y-intercept. And now we know that our slope is -2. And that means that as our x values are increasing, our y values are going to be decreasing. It's a little hard to show on this graph, but we can do it the other way. Basically, a slope of -2 means the rise over the run is going to be -2. So the way that we could do that is to have a +2 over a -1 or a -2 over a +1. Either one of those is going to give us the same thing as -2, okay? So let's say our rise, so we're going to use this one right here, +2 over -1. It's the same thing as saying the slope is -2, but it allows us to identify our rise as +2 and our run as -1. So we're going to go up +2 and the negative direction 1 and plot another point. Then we'll go up +2 and -1. Up +2 in the y direction, -1 in the x direction. And we're going to keep following that pattern, okay? So we go up 2, -1, up 2 over -1, up 2 over -1. And we're just going to keep doing that. And I hope that you guys can see the pattern that we're creating here. Oh, that point is in the wrong spot. So now we have all of those points that help guide us in creating our line. And then we just draw our line straight through those points. So I'm going to try and do my best to draw a straight line down through these points. It is definitely not perfect, but you get the idea. So just by finding our y-intercept and our slope, we were able to draw this line that is a close representation of the equation, okay? So there's my pretty fat line, but it gives you an idea of how this is supposed to look, okay? So I'm going to go ahead and let you guys do this on your own now for the second equation, y equals 5 minus 3x. So practice that on your own as you pause the video, and then press play to see how I do it. Okay, so in this equation, we have a y-intercept of +5. So we're going to go ahead and count 1, 2, 3, 4, +5 on our y-axis, okay? And our slope is -3, which means the ratio of rise over run needs to be -3. So we could get -3 by taking 3 divided by -1, or by taking -3 and dividing it by +1. Either one of those is going to give us the same slope of -3. So let's count using -3, +1. This means our rise is going to be -3, which means we're falling. We're rising down, going down 1, 2, 3, and +1 in the x direction. Down 3 and 1 in the positive x direction. Down 3 over 1. Down 3 over 1. All right, and if we wanted to do the opposite, we could go up 3, +3 in the rise, and then -1 in the x direction. No matter which way you do it, if you're following the correct ratio of rise over run, you are going to get the correct answer. So I'm going to go ahead and draw a line as best I can that passes through these points. I'll put a little arrow on the end to show you that it's going on for infinity in both directions. I wish I had my straight line tool today, but I don't. So there is the line of the equation y equals 5 minus 3x. Okay, let's go ahead and have you pause the video as you try to graph y equals 6x. All right, so y equals 6x, we're going to start with our y-intercept, which is 0. So that means we're passing right through the origin. And our slope is 6. That means the ratio of our rise to run needs to equal 6. And we can get 6 by taking positive 6 over 1 or negative 6 over negative 1, because remember, negative divided by a negative is still just a positive. So this is how we could calculate our slope. We could rise positive 6 and run positive 1. So we could go up 1, 2, 3, 4, 5, 6 in the y direction and over 1 in the x direction, and follow that pattern up. 1, 2, 3, 4, 5, 6 and over 1. Or we could do the opposite. We could go down 6 and to the left 1. And I should have written this earlier. This is our x-axis. This is the positive x direction. And we have the negative x direction to the left. Same thing up here. We have the positive y direction is up and the negative y direction is down. So that's what I'm using to remember which direction to move. So if I wanted to move negative 6 over negative 1, that means I would be dropping 6. So let's go down 6, 1, 2, 3, 4, 5, 6, and to the left 1. And if you notice, this stays in line with my pattern that I'm already drawing. Okay, the pattern for this line is already in motion, so it makes it pretty obvious which way you need to be moving. So there is the line for the equation y equals 6x. All right, we're going to do our last one, y equals 4. Go ahead, pause the video, and try to graph y equals 4. All right, so this one is a little bit trickier to graph. Remember, we have no slope. The slope is 0. And if you think about what that means in real life, think of a mountain slope. A mountain slope that has a slope of 0 is basically a flat piece of ground. It's even easier than the bunny hill. It's the bottom of the hill. It's just flat. A 0 slope means there's no slope. It means you're not going to move. So the y-intercept is 4. So we're going to go ahead and draw this little dot right here at 4. And the slope is nothing. It's like a flat piece of ground. We're not going anywhere. We're just staying put. And so our line is going to be flat, just like this. There's no slope. We don't have to count anything. We just know that the slope is 0, which means it's a flat line. So I hope that this gives you an idea of what positive lines should look like. Lines with positive slopes, like the orange line has a positive slope. And then how to graph lines with negative slopes, like the purple and green line, and also lines with no slope, like the blue line. So now that you have learned to draw a graph from an equation, we're going to work backwards, okay? We are going to work backwards and try to build an equation using a graph. So the same information exists on the graph that we need in our equation. So I'm going to do an example, and then the next slide you'll do on your own. So let's write an equation in slope-intercept form using the information from the graph. So remember, an equation in slope-intercept form needs a slope and a y-intercept. If we have those two pieces of information, it becomes very easy to fill the information into our equation. So we always write the general form of the equation, the one with all the variables. So slope-intercept form looks like y equals m times x plus b. That is the general form of our equation. And we need to find a value for m, which is our slope, and a value for b, which is our y-intercept. So I'm going to go ahead and just put m in parentheses here and b in parentheses here so you can remember which ones we're talking about. So let's look at our graph. The easiest thing to identify is our y-intercept. It's the location where our line crosses the y-axis, and that's obviously right here. It's up 5. So we know our y-intercept is going to be 5. So b equals 5. Now we need to find our slope. And this you do by just calculating the rise over run like we've done before. I also talk about finding the change in the x values over, the change in the y values over the change in the x values. You pick 2 points. In order to find the slope, you have to have 2 points. So let's just pick 3, 3 and 6, 1. And let's determine what the rise and the run is. So we'll start at 3, 3, and we're going to count down 2. Okay, we're dropping 2, and then we're moving over 1, 2, 3, positive 3 in the x direction. So our rise is going to be down 2, and our run is going to be over positive 3. So there's our slope. Our slope is negative 2/3. Now I want to show you that it doesn't matter which 2 points you choose. So I'm going to go ahead and find the slope one more time using the points 0, 5 and 6, 1. So in this situation, you could even do it this way if you wanted to. We're going to calculate our run. Our run is 1, 2, 3, 4, 5, 6. Our run is 6, and our rise is down 1, 2, 3, 4, down 4. So our rise is negative 4, our run is positive 6. And if you simplify that, that becomes negative 2/3. And if you notice, that's the exact same thing as we found originally. So once you simplify, it doesn't matter which 2 points you use, you're always going to end up with the same slope if you count the rise and the run correctly. So now all we need to do is use substitution. So we are going to rewrite the equation y equals mx plus b, but instead of writing the m and the b, we are going to use the magical substitution to substitute in the values that we found. So we have y equals 5x plus, instead of b, we'll go ahead and put in our slope, which is negative 2/3. And when we simplify that, we end up with the equation y equals 5x. And when we have plus a negative, it just means minus 2/3. So now you've written the equation of a line. I'll review the steps one more time. You find the slope. You find the y-intercept. You write down the general form of the equation, and then you substitute in the numbers. And that's it. So I want you to try this one on your own. This one is giving you 2 points. You should easily be able to find your slope, your y-intercept, and just substitute those values into the equation and go from there. Okay, I hope you had time to do this on your own. So let's start with the y-intercept. I always like to start with the y-intercept because I just think it's the easiest to find. It's right here at 1, okay? And the point is even labeled 0, 1. So if our line is crossing our graph when y is 1, so the b value is 1, okay? Now our slope is going to be the rise from this point to the next point. So we're rising from 1 to 4. So if you'll notice, the change from 1 to 4, that's the change in our y values, that's 3. So our rise is 3, and you could do it just by looking at the ordered pairs or by counting on the graph. And it's good to always check both, just in case your graph is not in units of 1. Okay, now we need to find our run. We're going from 0 to 1, so that's pretty obvious. It's just a run of 1. So our rise is 3. Our run is 1, so our slope is 3. That's going to be m. So now just rewrite your equation. Y equals mx plus b. Now, instead of putting the m, we're going to go ahead and put in a 3 for our slope. keep the x there. That's very important. And instead of the b, we're going to go ahead and add 1, which is our y-intercept. And that is your equation of the line. Y equals 3x plus 1. Okay, what if we don't have an equation in slope-intercept form? What do we do then? The answer is we're going to convert it using algebraic manipulation. And that is another video. So, once you feel good about slope-intercept form, then we can move on to working with standard form and point slope form and manipulating them to get them to be slope-intercept form, because really slope-intercept form is the most ideal form to work with in our situation for our class. So this is what we want to focus on, and in our next video we will talk about how to turn other equations into a form that we can understand.